So the goal here is to bring you to a higher degree of recurrence other than a of n equals a of n minus 1 and something. That's just a degree 1. But what if we wanted to take you to a degree like 4 or 5? Well, you can do that. And just a quick reminder, if you ever see a recurrence equation like this, make sure you solve for a of n. Okay, and then you can take it from there. And all we're going to do with each of these is just what we did in the activities. Get the first few terms. See if you can get the first few terms first. So, do the first 4 or 5. I usually need 5. Look for a pattern, and then derive your closed form. And then most of the time, if the question asks for it, then you're going to use induction to prove it. And we usually use weak, unless it says use strong induction. All of these are pretty cool. You've got, this is still a degree 1, but we can look at other degrees as well. And this one here, we did have a degree more than that. And I got you started here. So let's just get started on this one, see how far we can get before the bell rings. So a of n, I took this thing and solved for a of n. So I got a of n, 3a of n minus 1 minus 3a of n minus 2 plus a of n minus 3. What degree is this one? They're in the equation a of n equals, how many of these do you see? 3. So this is a third degree, as they indicated there. Good. All right. The reason it has 4 is you got to solve for a of n. Then if you just check for 3, 4, and 5, we have a0 is 0, a1 is 1, a2 is 2. Okay, so then I'm going to put in for a3 is going to be 3 times a2 minus 3 times a1 plus a0. So that's just going to be 3 times 2 minus 3 times 1 plus 0, which is just going to be what? 6 minus 3. 3. So now we know A3 is 3. Okay, now the next one. You're going to like this one to prove. Okay, so the next one you're going to have 3 times the previous is 3 minus 3 times 2 plus 1. So now you have 9 minus 6 is 3 plus 1 is 4. So now a 4, wait, this was meant to be 4 here. A4 is going to be 4. What do you think A5 is going to be? Yeah. So closed form, it couldn't be. You couldn't make it easier than this. AK is equal to what? Or they use n here. A of n is equal to what? N. Yep. So now we would prove that, and you would go n equal to 1. So does a of 1 equal 1? Is the first one 1? Yes. So therefore true for n equal to 1. Now do n equal to k. We'll do weak form. A of k is equal to k. And so, did they say strong?
Yeah, it's right there. No, it's right there in the bottom.
Yeah, strong. Okay. It's okay. Strong won't hurt you. All you have to do is r is less than or equal to k for r equal to 1, 2, all the way to k. Was that painful? A little. I know. Okay. So then we're going to say n is equal to k plus 1. So now a of k plus 1 is going to be what? K plus the previous one, which is a of k plus what? Plus 1. And a of k is k. Did we prove that? Yes, true. For n equal to k plus 1, and then you can state the rest. For tomorrow, just do number 2 and 3. And I think 2 is the only one you have to prove with induction. 3, 5, and 6, just find those patterns.
Hey,